Okay, guys, we are entering into the second phase of this, the second and the last phase of this binomial expansion for the for our P3. Okay, so if you look at these fractions over here, these partial, these rational functions over here, you must notice that all these binomials, they have a first term which is not 1. Okay, so we should have this first term as 1 if you have to apply a negative power onto this binomial. Okay, so now let's start with the first one, this 1a. Now this is 2 plus x to the power minus 2. We have to make this to 1 here. Okay, so this is going to be, if I take out 2 common from this, so what should I write this? 2 raised to power minus 2. So please remember, now suppose you have 2 plus x, okay? This is just 2 plus x, and you take 2 common from here. So this will be 2 into 1 plus x over 2. Suppose you had 3 minus x raised to power 2. And you have to take this 3 out as a common here. So what should be coming out as a common here? That would be 3 squared. You have to apply that power onto this this thing that is going to come out of the brackets here. So this is going to be 3 squared into 1 minus, and please remember you will be writing 3 over here, okay? Because though both of these terms, they have been divided by 3 and there is still a square on these brackets here, okay? Now suppose you have, yes, beta? Because, okay, let me tell you why this is 3 square, okay? Now, beta, look at this. Can you see that if these two girls are here, you can just give these to them? Oh, okay. Just 3 minus x whole square, okay? Now, if I write it like this, a whole square, and then I take a common, are you fine with this? And now you apply this power onto both of them, so this will become 3 squared into 1 minus x over 3 squared. So whatever is the power on these brackets, you have to apply that onto the thing which is going to come out from these brackets, okay? Now suppose you have square root of 5 plus 2x. So you want to make this 1 plus whatever, 1 plus whatever. So what would you write as a common here? Yes, that would be under root 5 into 1 plus 2x over 5. You may put the square root on it, or you can write the power half as well. Okay, suppose you have a minus x raised to power minus 1. So what should be coming out of these brackets as a common? You want to take a outside these brackets, okay? So this will be a raised to power minus 1 into 1 minus x over a raised to power minus 1. So please remember this. This is the point where majority makes a mistake while expanding these binomials here. Okay, so so let's get back to the question that we were trying to solve here. Okay, so I want this to be 1 plus something inside the bracket. So I need to take this 2 out of this bracket. So this would be 2 raised to power, I think I should keep it black. Okay, this is going to be 2 raised to power minus 2 into 1 plus x over 2 raised to power minus 2. You can, if you want, you can still multiply them together, because remember, we can multiply in 2 cases. One, if you, for example, if there is a squared times b squared, you can write it as ab squared. Like if you have 2 squared multiplied by 3 squared, what would be the result? 2 square into 3 square is 6 square. That is 6 square, okay? So if you have the same powers, you simply multiply the bases. If you have the same bases, for example, you have a square times a square. So then this becomes a raised to power 4. You add up the powers when the bases are same, okay? So here, the powers are same. If you want, you can go back to this if you want. Okay, so whenever you in mathematics you take a step, so you must see that if you can go back to the previous expression or not. Okay, okay. So suppose that you forgot to put this -2 onto this 2 while taking a common. So can I multiply 2 with 1 plus x over 2 raised to -2? Can I multiply them? Now, these two things, they neither have a same base, they nor have a same power. So we cannot go back to this thing if you just wrote it as 2. So this has to be 2 raised to power -2. Okay, now, you should immediately change this 2 raised to power -2 as 1 over 4. Okay? And now this is going to be 1 plus n x plus n into n minus 1 over 2 factorial into x squared. We have to go up to x cubed. Then we have -2 n into n minus 1 into n minus 2 over 3 factorial into the x cube and so on. Okay? So this is 1 over 4 into 1 minus x. So here I have, let me write in some other color. So this is -2 into -5 into 1 over 4 into 1 over 2. Okay, so this is going to be 2 cancel with 2. This isn't it 5 over 4? Yes, Bacho? Please check. Oh, I have, yeah. This is 5 over 4. Please check this. Is it really 5 over 4x squared? Yes? And for this one, this is going to be -2 into -3 into -4 into 1 over 8 into 1 over 6. So first of all, the final sign is going to be minus. I'm intentionally writing this with a different color so that, like, you know, this is a rough work basically. Okay. So this is 5 over 4x squared. And the next one is minus, the 6 is cancelled with this. Yes, beta? Why I'm writing 5 so much today? Yeah, you're right. This is 3. In the previous question, I wrote 5 instead of 3. Okay. So this has to be 3 over 4. Thank you for keeping an eye on my working. Okay. So yes, I hope the next one I have done that is correct. That is minus 1 over 2 x cubed. Okay. You will not leave your expansion like this because in your final expression, the coefficients of x and x squared, they should be clear. So you shouldn't be writing this as something into the things in the brackets. Okay, so you need to expand this fully. So this is 1 over 4 minus x over 4 plus 3 over 16 x squared minus 1 over 8 x cubed. Did you check the answer? Okay, so this one is right. Now we also have to state the range of values of x for which each expansion is valid. So we have this x over 2 over here inside here. So that is the common ratio. So this x over 2 absolute should be less than 1. So this makes it absolute x is less than 2. So this x is going to be between -2 and 2 if this expansion has to be valid. Do you remember that less than mark in the quadratic inequalities? There you have the values between the two roots, okay? So that is why this is between -2 and 2 over here. Okay, I'll be trying one more question.